The film Super 8, directed by J.J. Abrams, is critically acclaimed for being a modern homage to a more nostalgic era of filmmaking. But what about its accuracy regarding basic kinematic physics? Find out today in our one-part series, testing Super 8's accuracy regarding basic kinematic physics, not including the giant killer alien who builds a spaceship out of microwaves.
Today, we're going to be analyzing the train crash scene from the beginning of the movie.
I need to know this isn't the last time I'm gonna see you! I love you so much! Guys, watch out! Joe, what the hell?
Whoa! Let's take a look at that again. What appears to be happening is some guy wants to stop the train, which contains a giant alien. So he takes his pickup and drives for about 8 seconds, starting at rest, to try to accomplish this. In the clip, the first car of the train appears to reduce its velocity almost completely, while the truck completely stops and blows up. The first train car's sudden velocity reduction causes the second car to buckle up, derailing the train. For simplicity purposes, we are going to assume both the car and the train have equal momentum in opposite directions, which means they both stop when they hit each other. Also, for simplicity's sake, we are going to ignore the explosion created by the collision and assume the collision is near inelastic. Because momentum is conserved, we can say that the mass of the train times the velocity of the train plus the mass of the truck times the velocity of the truck equals the final momentum, which is 0.
To fill out the equation, we need both the masses of the truck and the train. The train modeled in the movie is a Baldwin S12 locomotive, and a quick Google search reveals it weighs approximately 106,000 kilograms, while the truck, a 1979 Chevy pickup, has a mass of approximately 4,400 pounds, according to the Chevy user manual, or 2 times 10 to the third kilograms. We are excluding the cars of the train from the mass because A, they are separate bodies that interact with the train after the initial collision, and B, the number of cars is convoluted and they don't necessarily have matching masses.
We will also need the velocity of the truck, which will allow us to solve for what should be the velocity of the train going into the crash. Good thing we found a video of a guy gunning his 1979 Chevy pickup on his way to Walmart. Analysis of the video reveals the truck was able to go from 0 to 60 miles per hour in about 11 seconds. A quick conversion tells us 60 miles per hour is 26.8 meters per second. So using the kinematic v equals v naught plus at, we can find the acceleration of the truck, which we will assume to be uniform, giving us an acceleration of 2.438 meters per second squared.
The guy driving the truck wants to be going as fast as possible, so it's safe to assume he gunned it as soon as he turned onto the railroad track. To find the velocity of the truck, we can use the acceleration of his truck in another kinematic to find his velocity after 8 seconds, using again v equals v naught plus at. Solving for v gives us a velocity of about 20 meters per second.
Now, let's go over the values we have calculated. The train has a mass of 106,000 kilograms, and we are solving for its velocity. The train has a mass of about 2 times 10 to the third kilograms, and is going about 20 meters per second.
Let's go ahead and plug in these values. This means in order for the train and the truck to stop each other, our initial velocity for the train going into the crash should be about 0.37 meters per second. Let's review the video again to see how this matches up.
Are we alive?
Clearly, J.J. Abrams messed this scene up pretty bad. Now with that, we'll end this analysis with a clip of a real train crash.